Alrighty, for this problem we have to find the general solution of the differential equation given below and the specific solution for the initial condition. Okay, so this is a two-part question, and the first part kind of naturally leads into the second. The second is just going a little step further. Okay, so let's start with this. So the differential equation given is this differential one. So it's basically the derivative of a vector-valued function. Okay, and another way to write this, I'll just write r prime of t is equal to, we're just going to pull out the coefficients here. So this is, and that's a 1. You can assume that's a 1. So r prime of t is equal to t squared, comma 5t, I didn't circle the t there, and a 1. Okay, so given this, what we're going to do is actually take the take the integral. We're going to integrate both sides with respect to dt, integrate both sides with respect to dt. Okay, so on the left side, all we get is r of t. So this is what we're aiming for, right? This is our general solution so far. And what we're going to have to do is integrate each of these with respect to dt, each of the components, right? So we're going to have something like that and something like that. Okay, so on the right side, what we get is random integral sign. I'm going crazy with the integrals here. So anyways, what we get is a t to the third, and then we have a 1 over 3, okay? And then you can write like plus c or plus, I'll just write an a, because right now this is an indefinite integral, right? So we have to write that plus some constant, okay? Come to think of it, I think I better just skip on down to the next line so we have enough room. So r of t, again, this is the general solution, okay, because we have our indefinite integral. So this is going to be 1 over 3 t to the third plus a. This is just a constant, okay? Remember, going back to like high school calculus or even like 31a, 31b, this is our constant that we have to add in for indefinite integrals. For the next one, we have a t squared, and then we have to have a 1 over 2 added in there, so 5 over 2 becomes that. And I'll add a constant, we'll just call it b, okay? Because again, we like the beginning of the alphabet for some reason. And this last one is just going to be a t plus some constant c. All right. So as you can see here, these ones, this a, b, and c, we can actually take those out and separate it, right? So our r of t could equal 1 over 3 t to the third, comma 5 over 2 t squared, comma t. And what I'm doing now is basically separating out the terms that include a t, so our variable, and the terms that do not include a t. So that would be our a, b, c vector. Okay, and commonly this is just referred to as a constant vector, and we'll just name it d. Constant vector d. Okay? So this is our general solution here. And I guess another way, a simpler way of writing it is just r of t is equal to 1 over 3 t to the third, 5 over 2 t to the second t, and then plus this constant vector d. Okay? So this is our general solution. This is the first part here. And now all we have to do is take into consideration what I'm going to circle next, which is our initial condition. Okay? And I'll write this on the next slide so we can continue from there. Okay, so r of t, our general solution, I'll write that down so we can proceed. Okay? And then 5 over 2 t squared and a single t. And then this was plus some constant vector d. And our initial condition given was that r of 1, when you plug in 1 for t, then we get j hat plus 2 k hat. So first of all, what is this? Well, we don't see an I, so the coefficient we assume is going to be a 0 for the I. So that's a 0, and then it's a 1 for the j, a 1, and a 2 for the k. Okay? Okay, yeah. Anyways, so this is our initial condition. This is basically saying when you plug in a 1 for the t value, this is what you're going to get on the right side. Okay? So what this means, let's see, how could we solve this? One way to solve for our constant vector here, our constant vector d, is by subtracting this entire thing, this whole like t terms, over to the left side. So if we do that, this is what we'll get. Our constant vector d is equal to r of t, okay, minus all of this. So minus 1/3 t to the third, comma 5 over 2 t squared, comma t. Okay, see what I did there? I just rearranged our equation up at the top here, okay? I'm just getting the constant vector d arrow by itself, okay? And now what we're going to do is just plug in a 1 in for the t's, so we can solve for our constant vector. So r of 1 minus 1 over 3, and we're going to plug in a 1 for all of the t's, okay? So if we're plugging in a 1, we get 1 squared, and finally a 1 there, okay? And in for this vector, we plug in our initial condition, okay? So this is going to turn into d arrow is equal to 0, 1, 2, all right? And then this is going to subtract. We're going to subtract a 1 over 3, a 5 over 2, and a 1, all right? So then what we end up getting for our constant vector, d, is 0 minus 1/3, so that's a minus 1/3, 1 minus 5 over 2, so that's a negative 3/2, and 2 minus 1 is just a 1, okay? So this is what we're going to plug into the top equation, which I just starred again. I'm just going to keep drawing stars for emphasis. Okay, so that's basically it, and now we'll just put it all together. We're going to take this d here and plug it in to right here, and that gives us our specific solution based on the initial condition. Okay, so r of t, this is our specific solution. Specific solution. Okay, so this is going to be, okay, wait, I'm having problems with that equal sign being so close. Okay, so this is going to be our general solution, basically. Just, we're going to plug in what we just solved for, which was our constant vector d arrow. Okay, so we have this as our first component, and then 5 over 2 t squared for our second component, and a t. And we're going to add our d arrow, which we found was negative 1 over 3, negative 3/2, and a positive 1. Okay, so this is basically it. This is what we found for our specific solution. Alright, so that does it for the practice problems video. I hope that helps on the homework, and happy studying!